Generate the logarithmic function that is the inverse of the exponential function g of x equals 10 to the 2x minus 3 minus 9. Okay, so the first step is to rewrite g of x as y. And then because we're finding the inverse, we can switch the variables y and x, and then we'll solve for y. So we get x equals 10 to the 2y minus 3 minus 9. So now to isolate y, work from the outside in and first add 9 on each side. So we get x plus 9 equals 10 to the 2y minus 3. Okay, so now we have our y up in the exponent, and we can't solve for y if it's an exponent, so we need to rewrite this so that we can get y just on normal, um, you know, as a normal variable that we can solve for. So the way that we can do that is by rewriting this as a log. And so we can rewrite this exponential as a log by saying log base 10. You don't have to put a 10 if it's just the base 10, and then of the answer x plus 9 equals, and then this is where it'll equal the exponent, 2y minus 3. And so now we can continue solving and add 3 on each side. And then to get y alone, we can divide by 2 on each side. So we get y, 2 divided by 2 is 1. And then we can rewrite this part as log of x plus 9 divided by 2. And then plus 3 over 2, or 3 halves. And then the last thing we can do to simplify this a little bit is just rewrite the 2 on the bottom as a 1/2 in front. And then we'll have, yeah, I'll just write it actually over here. And so we get log of x plus 9. And then instead of writing divided by 2, we can write times 1/2 in front. And then plus 3 halves equals y. And then the last step is just to rewrite y in our function notation, g inverse of x. So our final answer will be g inverse of x equals 1/2 log of x plus 9 plus 3 halves.